Hi students, welcome to today's class where we will be learning and talking about how to calculate density of a cubic unit cell for each of the three configurations of a cubic unit cell, which are simple cubic cell SCC, face-centered cubic cell FCC, and body-centered cubic cell BCC. Also, I will be showing you an example for how to calculate the density for a cubic unit cell for the configuration that I will tell. But before we begin, I would like to request, if you have still not subscribed to this channel, do subscribe, give it a like, share with your friends, and if you have still not hit that bell icon, do give it a hit so that whenever there's a new video posted on this channel, you get a notification and you never miss a video. So let's begin. So the density has a very peculiar formula which goes by D is equals to Z multiplied by M divided by Na multiplied by A the whole cube. So let me tell you what each letter means here. So D is nothing but the density, Z is nothing but the number of atoms in the cubic cell. Na is Avogadro's constant. Avogadro's constant, the value of which is 6.022 multiplied by 10 to the power of 23 per mole. And A is the edge length, which is different for each configuration. So this is what the formula is, and this is what each of the letter means. So now I will tell you the different edge length formulas and also the different packing efficiencies for each of the three configurations before I give you the example. So first is the simple cubic cell. Simple cubic cell configuration, or the SCC as we popularly know it by. So here Z equals to 1. If you want to know how we arrived at the value 1, there's already a video posted on my channel which teaches you how to calculate the total number of atoms inside a cubic cell configuration. So I would move forward here, and if you want to know how to calculate this, you can always go to my channel and see the video. Next is A, which is edge length. Edge length in case of a simple cubic cell structure is given by 2 multiplied by R. R here is nothing but the radius of atom. Radius of atom. So sometimes in the questions, instead of the edge length directly, sometimes the radius of the atom is given. In that case, you have to calculate A by multiplying 2 with the radius of the atom. So let me just show you an example. For example, if this is my simple cubic cell configuration where atom is present on each corner, and let me just project this. Let's assume, just excuse my drawing. I've just made this atom bigger. So this is the radius. So if you multiply this radius by 2, that is the edge length for the simple cubic cell. So this is the length of the total edge. So A is equals to 2R. I will now talk about packing efficiency, which is very important. Packing efficiency is basically how well or how efficiently the cubic cell is filled with the atomic structure. Basically, if I would like to give an example, if you take a jar and fill it with 3/4 water, I would say that the packing efficiency of the jar is 75%, which means that 75% of the jar is full. So that would be the packing efficiency of the jar. Similarly, in case of a simple cubic cell structure, the packing efficiency is equals to 52.3%, which means 52.3% of this cubic structure is filled, but the remaining part is empty, void. So that is what packing efficiency is. This should be by hearted because this can come directly in the form of an MCQ in an exam. So just remember this value. So now that we have talked about the simple cubic cell configuration, we would now talk about the FCC configuration. Let's go. So next one is face-centered configuration, or basically face-centered cell, FCC. So here Z is equals to 4. Again, you can always go back to my channel to see how we arrived at the value 4. A, which is the edge length, is given by the formula root of 8 multiplied by R, or you can say 2 root 2 multiplied by R. Packing efficiency, and this is very, very important. Packing efficiency for FCC is highest among all the three configurations in case of a cubic unit cell structure, which is 74%, which means that in case of a face-centered cell, 74% of the cube is filled, and only the rest of it, which is 26%, is empty. So now we'll talk about the body-centered configuration, and then we'll move on to the example. Talking about the body-centered configuration, body-centered cell, which is also called BCC. Here Z, or the total number of atoms inside the cell, is 2. The edge length is given as 4 divided by root 3 multiplied by R. And the packing efficiency is 68%. So now that we have talked about all the three configurations, let's go towards the example, whereby I'll teach you how to calculate the density for a unit cell. So, example. So in this example, I would be taking the example of silver crystallizing in an FCC lattice. So let me just write the question here so that it is easy for you to understand. So silver, Ag is basically silver, crystallizing in an FCC structure or lattice with A, which is edge length, given as 408.7 picometers. Remember, 1 picometer is 10 to the power of minus 12 meters, which is also equal to 10 to the power of minus 10 centimeters. And molar mass given as 108 grams per mole. You have to calculate the density. So we will simply apply the formula here. D is equals to Z multiplied by M divided by Na, which is the Avogadro's constant, multiplied by A cube. Simply substituting the values. Z here, we know FCC, so the total number of atoms will be 4, multiplied by molar mass, which is given in the formula, 108, divided by Avogadro's constant, which is 6.022, multiplied by 10 to the power of 23, multiplied by A. A is 408.7 picometers. So here I would like to, maybe let's say, I would like to convert picometers into centimeters. So if I want to do that, 408.7 multiplied by 10 to the power of minus 10, the whole cube. Because I want to calculate in centimeters, so that's why I multiplied by 10 to the power of minus 10. If I wanted to convert it into meters, I would have multiplied it by 10 to the power of minus 12. So this, you can always use a scientific calculator to solve. So you will arrive at the value of D being approximately equal to 10.51 grams per centimeter cube. So I have already done my calculation in the scientific calculator, and this is how we calculate the density of a unit cell, whereby the configuration is mentioned in the question. You will generally be given the A, the edge length value, and if sometimes the radius value of the atom is given, then I have already shown you how to calculate the edge length for different configurations, and the molar mass would be given in the question. Sometimes the questions would be to calculate the molar mass or the edge length. In that case, the density will be given. In any case, one of the variables would have to be found and the others would be given. So you can always use this formula to find any of the values. For example, let's say in a question, density is given, Z will be given indirectly. For example, if I say BCC here, BCC for the Z value for BCC is 2. Molar mass, for example, in a question you have to find molar mass. So in that case, density will be given, Z will be given, A will be given, and Avogadro's constant will be given. In that case, you will just have to find the value for M by substituting the values. So I hope today you were able to understand how to calculate the density of a cubic unit cell. If you have any questions or concerns, or if you were not able to understand something, I would be more than happy to have any feedback from you. Or if you have any questions, just feel free to leave them in the comment section and I will come back to you with the answers. Thank you, and I will look forward to meet you in the next class. Thank you so much.